Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're diving into the exciting world of concurrent collections. We're starting a new chapter on queues, and our focus for this episode is the BlockingQueue interface. Joining me as always is our Java expert, Victor. Hey Victor, are you ready to queue up some knowledge?
Hey Sheila, always ready to dive into Java's concurrent utilities, and I love that pun, very fitting for our topic today.
Great. Before we jump in, listeners, make sure you're familiar with basic Java collections and have a general understanding of concurrency. Now, let's start with a quiz question to get our gears turning. Here's the question. In a busy e-commerce system, where would you most likely use a blocking queue?
Ooh, that's an interesting question, Sheila. It really makes you think about the practical applications of BlockingQueue in a real-world scenario. I can already imagine a few potential use cases, but I'm curious to see what our listeners come up with. It's a great way to connect theory with practice.
Absolutely, Victor. We'll reveal the answer at the end of the episode, so stay tuned. Now, let's start with the basics. Can you explain what a blocking queue is and why it was introduced?
Sure thing, Sheila. A blocking queue is a special type of queue that supports operations that wait for the queue to become non-empty when retrieving an element, and wait for space to become available when storing an element. It was introduced as part of the Java Concurrent package to provide thread-safe operations for producer-consumer scenarios.
That's interesting. So it's like a regular queue, but with some special features for concurrent programming. Can you give us an analogy to help understand this concept better?
Certainly. Think of a blocking queue like a busy coffee shop. Customers, let's call them producers, come in to place orders while baristas, our consumers, prepare the drinks. If there's no space at the counter for new orders, customers have to wait. Similarly, if there are no orders to prepare, baristas have to wait. This is exactly how a blocking queue operates in a program.
That's a great analogy, Victor. It really helps visualize the concept. Now, you mentioned some operations. Can you tell us more about the key methods in BlockingQueue?
Of course, the main methods are put, take, offer, and poll. The put method adds an element to the queue, waiting if necessary until space is available. Take removes and returns an element, waiting if the queue is empty. Offer and poll are similar, but don't wait indefinitely. They can time out after a specified period.
I see. So, if I understand correctly, put and take are waiting operations, while offer and poll are more flexible with timeouts. Is that right?
Exactly, Sheila. You've got it. This flexibility allows developers to choose the behavior that best fits their specific use case. Sometimes you want to wait indefinitely, and other times you need to be able to give up after a certain time to prevent potential issues.
That makes sense. Now, let's dive a bit deeper. How does BlockingQueue ensure thread safety?
Great question. BlockingQueue implementations are designed to be thread-safe without external synchronization. They use internal locking or other forms of concurrency control to ensure that operations on the queue are atomic. This means multiple threads can safely put elements into or take elements from the queue without causing data inconsistencies.
That sounds really useful for concurrent programming. Are there any common pitfalls or best practices we should be aware of when using BlockingQueue?
Absolutely, Sheila. One common pitfall is potential deadlocks if you're not careful with how you use waiting operations. For example, if a thread tries to put an element into a full queue and never gives up, it could lead to a standstill if no other thread is removing elements.
Oh, that sounds tricky. How can developers avoid this issue?
Good question. One best practice is to use the timed versions of operations, like offer with a timeout, in situations where indefinite waiting isn't acceptable. Also, it's crucial to design your producer and consumer logic carefully to ensure a good balance between production and consumption rates.
That's really helpful, Victor. Now, I'm curious about performance. Are there any considerations we should keep in mind?
Definitely, Sheila. While BlockingQueue provides thread safety, it does come with some overhead due to the internal synchronization. In scenarios with very high concurrency, this can potentially become a bottleneck. It's important to choose the right implementation based on your specific use case and expected concurrency level.
I see. Speaking of implementations, I know we'll be covering specific ones in future episodes, but can you give us a quick preview of what's to come?
Sure thing. In the upcoming episodes, we'll be discussing array blocking queue, which uses a fixed-size array, linked blocking queue, which uses linked nodes, and priority blocking queue, which orders elements according to their natural order or a specified comparator. Each has its own characteristics and is suited for different scenarios.
That sounds fascinating, Victor. I can't wait to learn more about those. Now, before we wrap up, let's reveal the answer to our quiz question. In a busy e-commerce system, where would you most likely use a blocking queue?
Yes, the quiz. Well, a common use of blocking queue in an e-commerce system would be in order processing. You might use it to manage incoming orders. As orders come in, produced by the front end, they're added to the queue. Worker threads, our consumers, then take orders from the queue for processing, such as checking inventory, processing payment, and preparing for shipment.
That's a great real-world example, Victor. It really shows how blocking queue can be applied in practical scenarios. To summarize today's episode, we've learned that blocking queue is a thread-safe queue that supports operations that can wait for the queue to become non-empty or non-full. We discussed its key methods, the difference between waiting and timed operations, and some best practices for using it effectively.
Excellent summary, Sheila. I'd just add that we also touched on the importance of choosing the right implementation and being mindful of potential pitfalls like deadlocks.
Absolutely, Victor. Thank you for that addition. In our next episode, we'll be diving into our first concrete implementation of blocking queue, array blocking queue. Until then, listeners, keep queuing up your Java knowledge. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you're enjoying the show. See you next time.
Looking forward to it, Sheila. Goodbye, everyone, and happy coding.